So standard basis vectors. We use standard basis vectors to represent x-axis, y-axis, and z-axis. So how do we define them? Well, for x-axis we're going to use vector I, which is defined as, well, the first component is 1, the second component and third component, both of them are 0, representing x-axis. For y-axis we're going to use j, which is the first component is 0, the second component and y-axis is 1, and the last component is 0. So the second vector j, which has the second component equals to 1, represents y-axis. And finally for z-axis we're going to use k, which is 0, 0, and 1. The only component which is non-zero is the last component, and it is 1. So representing z-axis. When you have x, y, and z on x-axis, we can have this small vector with norm or magnitude or length equals to 1, I. Well, on y-axis, here we have j, standard basis vector, and finally for z, we're going to have this nice vector with the same length but in the direction of z-axis. Well, I expect you to ask, what are the lengths of these vectors? The length or magnitude of vector I is equal to square root of, well, we take each component, raise them to the second power, add them together, which is obviously equals to 1. The second vector, the same, 0 squared plus 1 squared plus 0 squared, square root of 1, equals to 1. Well, the last vector, vector k, is 0 squared plus 0 squared plus 1 squared, which is square root of 1, or 1. In general, if we have a vector with magnitude, norm, or length equals to 1, we call it a unit vector. So note, a unit vector is a vector with magnitude 1. In many cases, we're interested in taking a vector which has a large magnitude and rescale that vector to a unit vector. Well, how do we do that?